These are the examples for Algebra 2B, Credit 1, Lesson 13.3. Lesson 13.3, we're going to be talking more about exponential functions, this time with the base of e. E is that natural number. It's kind of like pi. It's a constant. It's approximately equal to 2.71828, and it's an irrational number. It keeps on going from there. And so that's what we're going to be doing. The good news is we're going to, a lot of what we're doing is going to be similar to what we've done in previous lessons. Problems 1 and 2, we're going to be talking about transformations. We did kind of, hopefully you can see this okay, we kind of squeezed all the information up here. We have the parent function e to the x, and like once again, we have our transformations a, h, and k. And just as a reminder, remember two things, two different ways that a can affect the graph. If it's a is negative, it reflects over the x-axis, so that's that vertical flip or reflection. Also, if the absolute value of a, remember that's just the number that's there without regard to whether it's positive or negative. Remember, because we already dealt with the negative being the reflection over the x-axis. So if the number there for a is between 0 and 1, the absolute value of a, that's a vertical compression. If it's more than 1, it's a vertical stretch. Also, remember that h, we have minus h, so that is the one that's counterintuitive. If the number in the function is positive or plus h is going to move us to the left, minus h will move us to the right. Finally, k is the nice one. It does what you expect. Plus k moves us up, minus k moves us down. All right, so let's go ahead and take a look at a couple of examples for problem number 1 over here. First example, we have g of x equals e to the x plus 3 plus 2. So notice here there's no number written for a, so we assume it's a positive 1. Remember, a positive 1 is going to have no effect on the graph, because remember, we're only concerned whether a is negative or if it's between 0 and 1 or more than 1. But if it's exactly 1, it has no effect. So the only two transformations are the plus 3 and the plus 2. Plus 3 is in the position of h because it's in the exponent. And so remember, plus moves us to the left. So that's going to translate the graph 3 units to the left. So translate 3 units left or to the left. And then 2 is in the position of k. In other words, it's not in the exponent. Plus k moves us up. So that will translate or move or shift the graph 2 units up. So just 2 transformations there on our first example for number 1. Our second example also just has 2 transformations. We're just taking a look at if these are minuses. So the minus 4 is in the position of h. Minus moves us to the right. So that would translate the graph 4 units right. And then, got one more to do still. And then minus 5 is in the position of k. Minus moves us down. And so that would translate or move the graph 5 units down. And so those would be the 2 transformations for number 1. For number 2, example for number 2, we have g of x equals negative 2 times e to the x plus 2 minus 4. Now here, we hope you see that there are actually 4 transformations. You say, well, wait, there's just the minus 2, the plus 2, and the minus 4. But remember, the minus here for a is its own transformation. So we've got the minus, the 2, the plus 2 here, and the minus 4. So 1, 2, 3, 4 different transformations. So remember, the minus is going to, when a is negative, I should say the negative, reflects the graph over the x-axis. So that would be a reflection over the x-axis. And so again, as soon as you see that a is negative, the coefficient of e, the number to the left of e is negative, immediately you know it's a reflection over the x-axis. All right, now the number itself, a is -2, but again, we're only concerned with the number, the absolute value of a, which is 2. 2 is more than 1, so that's a vertical stretch. That will stretch the graph out vertically. And that's a vertical stretch by a factor of 2, whatever that absolute value of a is. All right, so next, so that takes care of these two. Plus 2, now we talked about that in those first examples. Plus 2, that's in the exponent, so that's h. Plus moves us to the left, so that will translate 2 units left. And then finally, minus is in the position, -4 is in the position of k. In other words, it's not in the exponent like the plus 2 was. So that's how we know it's in the position of k. Minus moves us down. So translate, that will translate or move the graph 4 units down. All right, so just double checking everything here, making sure we're good. All right, yeah, I think we're good here. So reflection, whoops, we don't need to box the whole thing there, not just those two. Still thinking we're doing number 1 there. All right, so there we go. So 1, 2, 3, 4 transformations there. And then that is how number 2 will be in your packet. All right, number 3, we're going to be looking at Desmos, or we'll be using Desmos as we look at a word problem. And this is similar to something you did in the previous lesson. Let's go ahead and take a look at, we're going to read the question and then we'll put our own example up there. So here we go. It says technetium, well, the directions are graph using desmos.com and use the graph to answer the question. Round your answer to the nearest 10th or 1 decimal place. So we will do that. All right, so technetium 99M, a radioisotope used to image the skeleton and the heart muscle, has a half-life of about 6 hours. Use the decay function n of t equals n sub 0 equals e to the negative 0.1155 t, where n sub 0 is the initial amount and t is the time in hours, to determine how many hours it takes for a 250 milligram dose to decay to 16 milligrams. All right, so let's take a look before we go to Desmos. Let's go ahead and set up our function here. So we have n of t equals n sub 0. And for our example, we're going to have e to the negative 0.0578 t. And so in our example, the initial amount, and this is going to be, we're going to say that this is a certain type of insulin. And so we're going to say the initial amount, our n sub 0 is 30 milligrams, or 30, let's just say 30 units. And and we want to know how long it takes to decay to 8 units. And so we'll have another equation for that. All right, so the first equation we'll type into Desmos. N sub 0 we know is 30, so we have n of t equals 30 times e to the negative 0.0578 t. So that'll be our first equation. And then we want to know how long it takes for this insulin to decay, or to be have only be down to 8 units. So we have a second equation, n sub t equals 8. All right, so, and again, you could have used y here, y equals all of this, y equals 8, but we want to also get comfortable with the function notation. So let's go ahead and share our screen, make sure we're good to go here. And let's go ahead and share Desmos. It's going to come up in just a second. Okay. All right, so you should see that now on the screen. There we go. All right, so all we're going to do is type in those functions just as they are written. So we have n of t equals 30, and then e, and Desmos does recognize e as that constant 2.71828. So it doesn't see it as a variable, and that's good. All right, so whoops, we got an extra 0 here, didn't we? So let's fix that. There we go. I want to be careful on that. All right, excellent. So remember, to get into the exponent, we bring up the keyboard. We click this a to the power of b. That takes us into the exponent. And we type negative 0.0578. And then don't forget the t, because t is our input variable, taking the place of x. And then our second equation is n of t, kind of a short one, n of t equals 8, because we want to know how long it's going to take this insulin to decay down from its initial dose of 30 units down to 8 units. And so just like we had done previously, we want to see where the graphs intersect. Now, depending on if maybe your graph wasn't centered, start by clicking the home button, and you may or may not see the graph then. Of course, then you can just scroll out, and then pretty quickly you see the graph there. All right, so we're going to scroll in here and before we do that, though, let's just recognize we have our decay function there. So that's our exponential. That's our first equation that we entered. And the n of t equals 8, that's like y equals 8. We have that horizontal line that goes through 8 there on the y-axis. So we zoom in. We want to see where the two graphs intersect. Now, we already know we have n of t equals 8. So we expect the y-coordinate to be 8. What we're looking at, or we should say the n of t coordinate, what we're looking for is the x, the number that's in the x position. Of course, we're not using x, we're using t. But we're looking for that first number in the ordered pair. So we click, if there's no gray dot there, click on either graph, doesn't matter which one, you'll see the gray dot there. And as we expected, and as we knew would happen, 8 is in the y-coordinate position, but we're looking for the number that's the first number in that ordered pair. And we're going to round to the nearest, they want us to round to the nearest 10th, 1 decimal place. So we have 22.86. And let's go ahead and stop sharing so we can do that. And all right, there we go. And so we want to round to the nearest 10th. So the tenths is the first decimal place. And so we look to the next number to tell us how to round. So our two options here are to stay 22.8 or to go up to 22.9. Well, what do? We look to the next number, that's a 6. Remember, our stay numbers are 0, 1, 2, 3, and 4. Our go up numbers are 5, 6, 7, 8, and 9. So because 6 is a go up number, we're going to go up to 22.9. So our answer is 22.9. Now this was, I think in your packet, it's hours. So we'll just use hours here since this is kind of a made up example. So anyway, so 22.9 hours it would take for that 30 unit dose to decay down to 8 units. And that's something that's important because you definitely want to know, if you're a medical person, how long it would take a medicine to for the body to use it up, to process it, however that works. And so that would be important information to know. So kind of a real life example of that. All right, so that's what you're doing for problem number 3. And again, good luck with the work. Pause, rewind the videos, as we always say. And until the next video, take care and God bless.